I apologize for accidentally going down. I clicked the wrong button on OBS. That was my bad. I'm sorry about that. So I'm hoping you guys are having a wonderful, fantastic day filled with, you know, cool things or whatever. But if it's not a good day, you know, that's also fine too. I'm trying to set up Discord chat on the side here, but for some reason it's taken forever to load on my tablet. I'm not sure exactly what the problem is. So it might be a little spotty here and there if you guys are talking in Discord chat and you want to see it on stream. So sorry, Gathros, if that happens. Okay, so what was I going to say? I think while we're waiting on everyone to go in, I guess I will say that we had a lot that we did yesterday. So let's go ahead and CD into projects, simulayos, and same thing over here, CD projects, simulayos. And I guess it's Euler. There we go. So CD project Euler, right? So yesterday, if you remember, let me do a quick ls here. We created some very basic visualizations for like just using the Euler method for a gravity simulation. It wasn't anything fantastic or crazy, but I thought it ended up cool enough. So that'll probably go in the video just as like an intro slide or something like that. So if we do the last Mirage, I believe, we should be able to see all of the images. So here's the central planet being created, and then here's all the other side planets being created, or whatever you want to call them, and here they are just kind of moving around. I think it's really cool. Big fan of it. Yeah, big fan of this guy. I think it's super straightforward, understandable, clean, all that kind of stuff. Let's see, so yesterday we also started working on the plotting function, and we got most of the way done doing the plotting function. So today what I want to do is finish up that plotting function so that we can plot basic things, and then after that is done, I want to take the time to work on, what do I want to work on? I want to work on talking about the errors in the Euler method, because there are a whole bunch of errors in the Euler method, and I want to discuss why these errors occur. In particular, the errors come from instabilities in the code, and this really happens mainly with the forward Euler method, not the backward Euler method. So I want to kind of talk about this, explain why it happens and stuff like that. This weekend, I've decided that there probably will not be a video because I just don't have enough time to do all of the editing and stuff and get it out in the middle of the weekend, which is the optimal time for me. So I think from now on, I'll try to say my videos will be coming out Sunday at somewhere like 7 o'clock-ish a.m. my time, and if they don't come out at that time, then I will probably I will probably not put them out that weekend. I'll put them out the weekend after. Hey JSPP, you missed a little bit from yesterday. I just played the animation. I guess I'll play it again, but we went back to the Cairo visualization library instead of the OpenGL one, which means that we're able to like do very basic visualizations, something like this. So here's, for example, just a whole bunch of small asteroids going around a planet or something like this. I don't really know what you'd call it. But it's kind of a cool animation. And so we'll kind of do something like this. The idea is that we're using Euler methods kind of like we used the Relay algorithm before, just having a bunch of, doing a very large scale gravity simulation. Because that one's relatively straightforward to work with, and it's understandable because pretty much everyone knows the kinematic equation. So once we move on to other things though, I mean, the Euler method is powerful because it can be used for other things that are not necessarily a gravity simulation. So that means that we can do a whole bunch of other cool things that we couldn't do before. As a quick note, I want to try something real quick. So I want to go into VI Euler.cpp. Where is it? CPP. And I want to change the size of this one more time to something a little bit bigger, and I just want to check what happens as I run it. So I'm going to try maybe, let's try 1,000 by 1,000. Right, quit. Now let me think. I think I set the radius and everything to be like, yeah, so I don't think this is going to change too much. Let's just go ahead and do that. Let's make this over here. And I'm going to check top when I'm running this. So I'm going to run Euler here, and I'm just going to run top over here. And I want to check in particular how much RAM it takes. Ah, it's a segmentation fault. Great. So that might have been the reason why I ended up dropping this visualization library in the end. Let's try 1,000 by 500. Make that. Euler. And it's also segmentation fault. Wait. Am I doing something stupid here? Let me try 400 by 600 by 400 or something again. Euler. I know this one worked just a second ago. What? No way. Did I not just run this one? 1 second. Let me do git status. Sorry, git diff dot. There's literally no difference. So I didn't make any changes. Make clean? Make? I'm not actually sure what I need to do here. Try running it again. What? Why am I getting seg faults all of a sudden? I swear this was working yesterday with the same exact code. So far as I'm aware, unless I did something really, really dumb here. So I guess I'm going to run GDB and then run Euler. And then let's do quick run here and backtrace. Euler ball at 102. Let's see what happens there. Cairo viz at 185. Draw filled circle. Okay, let's take a look at that one then. So let's go into first the Euler ball. So we're going to go into vi Euler.cpp and we're going to look at 102 here. So it's draw filled circle. That should be still correct. I don't see any reason that would be incorrect. So let's go into vi visualization, Cairo, and then Cairo viz.cpp. And let's go into, let's see, 185. So it says Cairo arc, which again shouldn't be a problem. Man, am I doing something stupid here? Radius 10, circle color equals circle color, draw frame is equals 302, origin, animation. Wait. Origin, animation, draw filled circle. It's actually missing something there. Let me think. Radius equals 10. Everything's kind of different here real quick. Let me see. Radius equals 10. Draw filled circle. I only have one of these functions, right? Because it's saying radius equals 10, but my first call is animation, then origin. 1 second. Then radius. Oh, why are these all mixed up? I'm not really sure. Maybe it's something that I should know, but I clearly don't. So let me do a quick, I guess I'm going to look into, let's cairoviz.h, see what happens there. And let's go into draw, fill, something, and animation, origin, yeah, it looks like it should be okay. I'm not really sure what's happening here. Let's go into Euler.cpp. It's obviously a problem with the Cairo library and drawing things, but I don't understand why it would be a problem today, and it hadn't been a problem for the past, like, year using this, basically. Let me think. So we have the initializing of the layers, but again, that should be fine. G down here. Let me try the test visualization again. Control D. No. Wait, Control D, yes, is what I actually want to do. cd.visualization. cd Cairo. And yeah, this should be okay. So let's run make. And let's run ./viz test. Okay, so this one seems to work. And if you remember, this was the plotting function. So let's run the last mirage. And I think I actually know what the problem is now. Which is good to know, at the very least. Let's pop up here. I know exactly what the problem is. So if we go into visualization Cairo.h, I defined its number of frames too low. Let's change this back to 1,000. This is my fault. I need to find a better way to do this, but I'm just being an idiot for now. So we're going to go back into the Euler code over here. And then if we run make with that guy, it should work. So let's go into right quit. And let's go into Euler.cpp. And let's change this again to 1,000 by 1,000. What I want to do is check top, see how long it takes to run, and what the memory usage is like. So let's make that. And while that's running, let's go ahead and pop up top. And then we're going to go over here and run the last Euler call, which should be right there. Okay. In particular, I'm checking the RAM. I'm a little bit worried that this is very RAM heavy. In fact, I'm quite worried that it's very RAM heavy because of the way that I'm doing it. So in principle, it doesn't look too bad. Not even htop. I'm sorry. Wait, should I be using htop? I'll use htop. Let's see what that one does. Man, Buttercake just knows everything. I don't know anything. Yeah, so Discord's not loading. I'm gonna try to maybe reset it over here on the side and see what happens. I don't know. It's for some reason not loading on my tablet over here. So I'm not gonna be able to check Discord today. Sorry about that. Anyway, give it still some time to run. Why does your top look so different than mine? I don't know. I'm probably running a better distribution of Linux and probably just a better person overall. So I have a better top, if you know what I mean. Okay. So that wasn't so bad. I'm sorry for the yawn. That wasn't so bad. So let's go ahead and run the last Mirage. Okay. So this is a 1000 by 1000 image, which is exactly what we want. So we're going to scroll down. 1 second. I'm kidding. Let's see. So here we have this. But that looks okay. There we go. So then we have these guys. Yeah, all right. I'm okay with this. Yep. This looks pretty good. Good. Okay. Just checking that. Let's do Q. Let's do H top. Ah, dang it. I apparently had not heard of it. I thought it was a standard. Let's see. I thought it was black and white, isn't it? Am I wrong? Oh, yeah, I can't read that. That's crazy. I just want to see how much... Okay, fine. It tells me how much memory, what all my cores are doing. Sure. Okay. Fair enough. Q. Fair enough. Let's see. T2 Designator, Buttercake, JSPP, Gastorn. Thanks, guys, for coming in. By the way, would Task Manager even work in Wine? I don't think so. I don't think Task Manager would work in Wine. I don't know why you'd want to use Task Manager, honestly. I don't really know what it does. Oh, wait a minute. Discord, I think, just started working. I'm actually not sure. Anyway, it's fine. Doesn't really matter. Okay, so that's good. That means the memory, I guess, footprint isn't so big. I was worried it would be very, very large, but that should be okay. So for now, let's go back and start working on the plotting function, get that guy plotted up, and I'm hoping that it'll take maybe 30 to 45 minutes. After that, the idea would be that I can then start working on describing the difference between, like, I guess you could say time steps with the Euler method, and showing why there's like huge instabilities at certain points. That might take some trial and error. I'm not sure the best way to describe it, but I do want to highlight the fact that the forward Euler method does have a whole bunch of instability problems if you have a certain time step and certain issues here and there. So that's something I wanted to highlight. And that's also why I'm not going to do the video out this weekend, because I want to take a good bit of time revising the algorithm archive article this weekend, so that when I'm writing the algorithm archive, it looks clean and clear and fresh and understandable, all that kind of stuff. And it clearly leads into Gaussian elimination and clearly leads into backwards Euler method and stuff like this, so that people understand why there's a need for the backward Euler method to begin with. And heck, maybe even while we're talking about backward Euler, we talk about the Crank-Nicholson method at the same time. Because honestly, they're both, I guess, implementation-wise somewhat similar, but they are quite different in some ways. So we'll talk about that when we get there. As far as the schedule coming up is concerned, I mentioned this on Discord, but in case any of you guys are not on Discord, which, by the way, if you want to get on Discord, it's pretty cool. Just feel free to go here. Discord, it's pretty good. I mentioned this on Discord. As far as the future programming is concerned, the idea is quite simple. Also, the fact that we have both Buttercake and Nightbot giving the link. Oh, I see. So Discord created Nightbot's link, and then Buttercake echoed the link that Nightbot gave. That's okay. So what was I going to say? So for the future of the LaosOS YouTube channel, the idea is the following. This upcoming weekend, I'll be working on the Euler video. We'll see how far that goes. I might be able to create the video, but it's not going to be out until next weekend. I'm just going to wait a week, make sure that it's fully ready to be released. In particular, make sure the algorithm archive article is up and good to go. The next one that I want to do is probably going to be either Huffman encoding, or Gaussian elimination, or maybe number theoretic transforms, something like this. I'm not really sure. The thing is, unfortunately, for the first week in March, so let me go ahead and, what was that nonsense? How did that happen? 1 second. I had to have set up a keybind for it. So what would that have been? Control Shift T? Oh, wow. Oh, I have something in here that's pretty cool. I choose you. What's your favorite Pokemon? Quick, someone, tell me your favorite Pokemon. What about middle out encoding? That's something I hadn't really considered before, but I'll write it down on the list. There's a lot of encoding stuff that we can go into if we wanted to go into Huffman stuff. Okay, no Charmander. Great, let's do Charmander. So I have this thing. It changes your terminal to look like Charmander or whatever Pokemon you want. So if you do like I choose you, I don't know, like Miss Drivus is my favorite Pokemon. You get this one. Your favorite Pokemon is Cat. Then if you do Squirtle, I really like this thing. I misspelled Squirtle. I really like this thing. It has like all of the Pokemon. I don't know at what point it quits. Here, let me check this out real quick. Let me go to Cerebi.net and let me just look at one of the most recent Pokemon. I've got a feeling it doesn't have Generation 7. It probably quits out at some point. What generation does it have? Sun and Moon. No, the colors. It doesn't change the text colors, but it changes the background. There is a cat Pokemon. Let's try Litten. No, Litten doesn't exist. Let's try Meowth. There we go, Meowth. And Persian. Yes, I don't know exactly at what point it quits. So let's try, what's Torterra? Okay, so how's up to the 4th generation? What's one, Victini? Would be one from the 5th generation. What's one from the 6th generation? Talonflame? Okay, so it doesn't have the 7th generation, but it has up to the 6th generation. So it doesn't have Litten, which is from the newest generation. So let's do Litten. Yes, so it doesn't have the 7th generation. So it doesn't have the Alola region, but it has up to... Okay, look, I'm sorry, JSPP. Out of nothing, Jaleus turns into a Pokemon Pro. So when is your first Pokemon gaming live stream starting? Okay, I'm sorry, fine. I'll quit this. I thought people were interested. I thought you guys liked the whole... Okay, fine. Fine, whatever. I get it. I'm a nerd. I'm sorry. Speaking of which, if you are interested in Pokemon, which you might not be, Cerebi.net is actually a very good place to find all your Pokemon information. I'm a big fan of that website. Used to go to it almost every day. Anyway, let's move on to other stuff. What was I saying before that? Before that, I was going to talk about the programming of Laos OS, and I was going to say that I'm not sure exactly the best way to go there. I think, because we already have the Huffman encoding video up. By the way, I want to go into Huffman here, do a quick ls, and I should have frames available. Yeah, let's go into VI frames. Actually, not VI, Mirage. Frames. And then image 00000.png. Okay, we did Huffman encoding a long time ago, and we made this really cool animation that I really like. It's so cool. But I never turned this into a video. So I kind of want to just do it, you know, finally turn it into a video. And I figure that since I'm going to be traveling the first week in March, and I already have the audio pretty much taken care of for this video, I can just go ahead and do it, you know? So that's what I think I'm going to do. So what I need to do is I need to do the Euler methods, then the Gaussian elimination or something like that to solve the backward Euler method. Then we do, I don't know, like maybe Huffman encoding, something like that, not sure. When are you releasing the public version of 0.1, the Simulate operating system? Here's the thing, my YouTube handle is Laos OS, which by the way, I now realize is confusing. You obviously don't realize it's confusing when you start the whole thing, but I now realize it's kind of confusing because it's like Lay OS, you know? But I was thinking about starting, like pretending to start writing an OS for April Fool's Day or something like that. So like on April 1st, be like, so this is the first version of the Laos OS operating system, or Laos operating system, and like have it be like some weird AI thing that clearly doesn't make any sense. I don't know. I'm not very good with the whole humor thing, I guess. Man, I still like this animation. I think it's quite good. Okay, so let's keep going. Was there anything else that we did back in the day that just never came out? I think there's a lot of stuff here. Like, for example, the eigenvector stuff. we actually did the Lanczos method. We showed how to find eigenvalues. That was really cool, and I just never made a video on it. Man, there's so much stuff here that I just never made a video on. Optimal control. I don't know, plasma fractal stuff. I don't know if I ever finished that. Tunneling, relay, viral video, visualization, or sort. You know, we have a lot of this stuff. But the viral video stuff, whatever happened to that? What happens if I just run viral video? I'm not really sure what'll happen. Maybe this is a bad idea because I don't really know what I compiled. I probably should just played that out.mp4 that was just sitting there in the directory. So Simulate.os is the enterprise and Laos.os for the normal users. Yeah, probably something like that. Some sort of Fedora Red Hat split. Did I miss? If I missed anything in chat, please let me know. We're gonna go ahead and get started on the. Ooh, look at that. Let's see what this is. Mirage, temp, image. Oh, this is gonna look crap. I'm pretty sure it's gonna look crap. Okay, so let's see. What did I do? I think, if I remember correctly, we drew a distribution of people. There's our people. Yeah. Okay. So here's our people being created. Then what we did is we plotted the people who initially watch a video, and we watched how this, let's see how this changes. Yeah, so then more people watch the video, more people watch the video, more and more. Okay, so we watched how the video is distributed across this network, and how it can create viral-esque videos. This one didn't go viral though. Yeah. Man. I did so much stuff for this, and it never came out. Man, we did so much stuff on this channel that never came out to a video in the end. Not that the video is like the ultimate goal of anything we do on this channel, but it is kind of nice when we can wrap it all up into a single concise video and then put it on the algorithm archive. Like, I like that workflow. Okay, so what we're going to do is cd back into ls cd into visualization, ls here, and we're going to do quick cd into // visualization. 1 second. And Leo's sad memories. I'm not sad about it. I mean, the thing is, we've done a lot more on Twitch than we did on YouTube. And this is something I realized very recently. My YouTube channel is super basic, you know? There isn't anything in there that's like really complicated or hard to follow. I don't think. Except for maybe the 4D video, but even then, like the whole point in the 4D video was explaining that all it is a projection from 4D to 3D. And if you just quit thinking about it if you quit thinking about the question, what is the fourth dimension? And you think about it as, there is a fourth dimension, how do I see it? Then it makes sense. And that was kind of the point of the video, to show, hey, here's a projection matrix. You just go from 4D to 3D with the projection matrix. The determinant video might have been complicated. In fact, it probably was complicated. That was probably the most complicated one to follow. But everything else is rather straightforward. With the exception of the stable marriage problem, which seems straightforward. But that was the thing. I realized yesterday, I have no idea what my audience on YouTube wants, or what you guys on Twitch want. For me personally, if I see a video that has the word algorithm in it and it's short, I will watch it. Because I like algorithms and I really want short, intuitive pictures. But I also realized this the other day, and I guess I want to hear your guys' thoughts on this a good bit. Because I always hate... Let's try before I wait until after stream. Oh yeah, fair enough. I'm sorry, Buttercake. What was I going to say? Here's what I was going to say. I want to hear your guys' thoughts on this. I've mentioned before that I don't like lecture content. I also don't like long videos. And I think I figured out last night why this is the case. It took like literally 2 years of me thinking about why I just dislike this stuff. But I think the reason is that lecture content, longer videos that describe everything that's going on, you know, like this type of learning content in video form spoils the plot for me, you know? So the truth is, like if you're watching a movie or you're very invested in a television series or you're very invested in a book or something like that, you know, the issue is that if someone comes up to you while you're reading this book and says, oh, Harry Potter dies at the end, or they say the same thing in the movie, like, oh, Harry Potter dies in the end, you know, that's a plot twist. And you as a reader of this story or a watcher of this series will become very upset at this because they're spoiling the plot. They're ruining the fun that is in inherently in this world that you're reading, you know? But for me, I think that comes with learning. I very much enjoy learning. I very much enjoy figuring things out. Some of the most enjoyable moments I've ever had are me sitting at... I have no idea, Gwenarth. I made that up. I've never actually read Harry Potter. But the thing is, some of the most enjoyable moments I've ever had are the... I don't know if he dies or not. I'm so sorry. But some of the most enjoyable moments I've ever had are when I'm just sitting on my couch, listening to some very light music in the background, reading a research paper. Because these research papers, they don't hold your hand, you know? They give you enough information that you can kind of piece together what's happening, and then you have to puzzle it all together. You know, you have to put one piece together, another piece together, another piece together. And this puzzle, this putting together the puzzle that is the knowledge in the end that you want, that is the fun part of learning to me. And so when I'm sitting in a lecture and they're fully explaining everything, it drives me nuts because I don't learn this way. I don't learn by people giving me a puzzle piece and telling me to put the puzzle piece down. I learn by them giving me all the puzzle pieces and then me figuring out where they fit, you know? And I think that's why I don't really like lecture content and why I don't really like these longer videos for educational content and things like that. Because in the end, the fun of learning comes from figuring it out. And if people figure it out for you, and they give you that information, it's like they took all the fun out of it, in a way. And so I guess it's because I very much care about learning that I dislike this type of content. And to me, I feel like it's the same as people spoiling books or something like that. You know, if they tell you what's going to happen in the end of the book, they lead you through it, they say, here is all of the plot twist that's going to happen in the book. I feel like that really ruins the experience for some people, and I feel it's the same for me in lecture content. So I think that's why, no matter what I do, I'm not going to really change my content up too much. Because for me in particular, I really am interested in, what am I going to say? I'm really interested in having a channel that goes through very briefly, this is what you want to know, like very briefly, this is all the information you need to know to implement this. I did this with the 40 video. I was like, hey, here are projections. I've done that with like Euclid's Orchard. I was like, hey, here's Euclid's Orchard. If you want to use it for something, go ahead, you know? Like I did this with all my videos so far. It's just a very brief introduction. Here's all the stuff you need to know to implement it in code. That's it. And then from there, the implementation is the fun part, you know? I missed a whole bunch of chat there. I apologize. I was kind of rambling. We want My Little Pony and ice cream cake. I don't have either of those. I'm very sorry. Non-sensation, at least no one will miss the Discord channel if it's linked twice. Yeah, that's totally true. Does Harry die at the end? I really don't know, Gwenarth. I'm sorry. I don't care so much about spoilers. I reread books a lot. I do the same thing, Gustorn, but I think it's because when I'm reading books, I enjoy the writing of the book more than the story of the book. He dies hard. Oh, I guess he does. I can never watch the movies. Same. There are also some books I read 9 to 10 times. Also true. There are some books that are like 20 books long and they're huge. I'm more interested in the actual use case implementation of algorithm theory rather than the pure and solely theory algorithm behind it. That might be true. I guess that has to be true if you say it. But I don't know. I tend to find that for me in particular, I don't care so much about where it's used. Just that it's an algorithm and that it's interesting. Like it's a method. I'll find places to use it. No matter what, there will be a place to use it. And that's also kind of the fun of it, you know, like if you're in the middle of work and you're doing something, then all of a sudden you're like, wow, I could use this algorithm to solve this problem. It becomes amazing, you know, like that's really, really cool because you're like, you know, all of a sudden you just find it, you stumble upon it. It's now useful when you hadn't thought about it before, you know, like it was hard for me to learn the theory of regulators, but when we applied it at university to stabilize a ball on a plane, it became clear that those equations actually do. Yeah, maybe. Yeah, I can see that, but the thing is, I feel like algorithms aren't purely theoretical. Like, you use it for a simple case just to test to make sure it works, and then you know how it's used from then on. You know, it's a tool in your belt, under your belt, that you can then use for literally anything. And you'll see, as you're doing things, where it's used. But yeah, that's kind of it. I'm sorry, the Gathros, if you're saying things, I can't see you in the Discord chat. It's not connecting. I apologize for that. I'll try one more time to reset it, but for some reason it's not connecting on my tablet. Wait a minute. Oh no, it still says connecting. Dang it. Anyway, it doesn't really matter. Yeah, this is kind of what I was trying to figure out, what you guys thought. So it seems to me like you guys want more concrete, practical use cases, which is fine. Let me think. But I don't know. For me personally, that's not how I learn things so well, you know? In fact, I learn things better when it's completely disconnected from other things. And then I find places to use it, like I said before. Like every once in a while in research, not every once in a while, like pretty much every day in research, I go and all of a sudden I'm like, wow, I could use this algorithm to solve this problem. And the only reason I know that algorithm is because I learned it on the side, just because I had fun learning it on the side. And so it was totally fun. Like for me, the learning was really fun. Then after I did the learning, all of a sudden it's like, wow, this totally cool thing that I learned the other day is now useful in the research that I'm doing. That is amazing, you know? And that's kind of the way I do it. Anyway, let's CD back into visualization and then Cairo. Let's get something done today. CD Cairo. Again, I want to get the plotting function done so we get a very basic plot created. And then after that, I want to do, what do I want to do? I want to go back and check the errors of the forward Euler method. Again, guys, if you have any comments, questions, concerns, anything like that, feel free to leave it in the chat and I will totally address it as soon as I see it. And have time to fit it into the conversation. I'm doing my best not to be as distracted by chat anymore. I used to be incredibly distracted. Like the moment something popped up on chat, I would just like immediately start talking about it. But actually now that the chat's smaller and on the side, it's easier to be less distracted by it. So maybe there's some benefit to the asymmetry in our current layout. Let me get some water real quick. Okay. So what should we do? Let's go ahead and take a look at what we have so far. So I'm going to go into VI. What am I going to look for? Viz test. Oh, how about CairoViz.h? And again, there's a lot of things we need to change here, but for now, this is what we have. And I'm going to go through and probably update everything accordingly, or as soon as I can. By that I mean I'm going to try to make this library a little bit better, a little bit cleaner, easier to use, that kind of thing. But I'm really liking the fact that I can kind of scroll through the images. I had forgotten how useful that was. And I know, as you guys said yesterday, we could do that also with OpenGL. I'm just really bad with OpenGL. That's kind of what I learned. In the end, my OpenGL streams, like, I just did a lot of visualization. Okay, one second. Where are the... Oh, nope, I missed it. There is... I'm looking for something, but I'm not seeing anything. I know yesterday... Ah, there it is. Right there. 1, 2, 3. Okay. So here is the array that we were trying to plot. But for some reason, there's two problems with it. One, so here I'm scrolling forward in time, right? So then that's our array. Our array for some reason just plots all at once. And then after that, it slowly goes away when it should do the other thing. It should not be created all at once. There should be nothing there. And then it kind of moves around. Yeah, .h is, you guys got it. Thanks, guys. Okay, so let's see if we can figure out what the problem is. First of all, the array is flipped around, flipped upside down, so we can fix that one relatively straightforwardly. Am I in the .h file? I think I am. So let's go into vi CairoViz. Actually, yeah, CairoViz.cpp. And let's just pop down to the bottom where we had the plotting function. Now, the issue here is that we have this origin.y, and what I need to do is minus instead of plus here, and that should flip the array around. Okay, so that does that. So now we have to figure out what is happening here. So I equals 0, I less than array.size, plus plus I. So now we're going through all of the elements of the array. We have some sort of current time, which is going to be equal to I times dt. And then what we want to do is animate the line being drawn from start frame to the end frame. So we have start frame, and then we have start frame array plus current time times animation FPS. Sounds good. dt. And then we do vector array minus 1. Vector array I. And let's see. First of all, I think this has to start at 1. See what happens. R1. Let's go over here and make that. This should flip everything around. Stack Overflow. There's no such thing as C in C++. Question is closed off by topic. 1, 2, 3, 4 users. Where is that? Could you send a link to that one? That one's quite funny. Or at least it seems like a good joke. Okay, so let's scroll down here. Looks good to me. And let's see, the array should be flipped around. Wait, where is the array? Ah, there it is. Is that the same array we had before? Did I run it? Maybe I didn't run it. Yeah, I didn't run it. Okay, let's try it again. Viz test. Okay, so let's do Mirage here. And take a look at what we have. Here we have the graph appearing up there. Yep, looks good. And we should have, I feel like I missed it. Where are you, babe? Come on. There's like one frame where I see you. There you are. Okay. 0, 1, 2, 3. We're also missing the final element. That's useful to know. I just don't get why a lot of communities are so toxic. Wait, what do you mean a lot of communities are toxic? Are you talking about the Stack Overflow community being toxic? Or are you talking about Twitch communities being toxic? Because I have a theory as to why communities get toxic in the first place. They're just pedantic. Anyway, let's see. So this array is correct, except the last element isn't there. So let me take a look and see where that element is. So let's go into VI source, and what I want to do. No, not VI source. What am I looking for? I'm looking for viz_test.cpp. Pop down here, and we should be in main. It looks like the array is... Oh, it's only 4 elements, so this is actually correct. Yep, it's fine. Oh, sorry for the yawn, guys. Okay, so what I want to do next is quit here and figure out why it's not drawing in time. Actually, Twitch is quite good moderated. Toxic beings have problems with their ego, I guess. Actually, I was curious to see what you guys thought about this. There's a lot of just YouTube comments. I know everyone says don't go to the comments because they're completely toxic, but I address almost every single comment that I get. I think I might have missed like maybe 10 in my entire YouTube career, which sure is a long career, and I only get like 20 or maybe most 20 comments a day. Usually I get under 10. But I respond to all of them. Every single day I take time responding to comments. And the reason I do this is because, in my opinion, it's good to address the trolls, you know? Because every once in a while there's a troll. Like, again, I said this the other day. Like, there was one guy on one of my videos who came in and just said, F you. That was his entire comment. So my comment back was, hey, I'm sorry if I offended you in any way with this video. I hope you have a wonderful day. That was it. Something like this. And they said, nah, dog, you just completely blew my mind with the video. The second comment immediately after was, you're a really cool guy. The third comment was, I just subscribed. I'm looking forward to seeing your stuff. And I'm like, hey, this guy was a comment that I wasn't considering just deleting. And instead I was like, hey, let's talk to the guy, see if he's okay. And it ended up being one of those guys that was very happy with the fact that I commented on his stuff. And honestly, most of the other trolls that I comment to, like, or I respond to, they end up either deleting their comment or getting, or somehow, I don't know, like, how do I put this? They end up becoming people in the community that I actually respect, you know? With exception of one guy who came on Twitch. That guy was Frank, and Frank just, I don't know where he is, but I'm glad he's not here right now. He's probably in chat. He's gonna come in. I'm waiting for it. On Stack Overflow, if you want to know, sorry about that. On Stack Overflow, if you want to know something minor, you can ask a question, as it's to a broad off topic. And in chat, you get roasted and ignored. Yeah, fair enough. I remember that FU. I never asked a question in Stack Overflow since all the questions were already there. Pretty much. Non-sensation. You gotta have thick skin, I guess. No. Buttercake, do you remember Frank? Were you around when Frank was here? He used to just come on, and he'd be kind of sort of nice until Gustorn came on, and then he would rip Gustorn to shreds, and I'm like, Gustorn is a nice guy. Why are you being so mean? Anyway, it doesn't matter. He was just a troll. He was a troll. Nothing more to say there. What was I going to say on top of the Stack Overflow stuff? Yeah, I'm wondering. I want to hear your guys' opinion on this too. And I apologize, I'm just rambling again. I always ramble. But Jeff Atwood. Coding horror. There we go. Coding horror. This guy has a very how do I put this? Very negative opinion about a lot of things. Now, I'm not saying he's wrong, but his opinion tends to be very ranty and stuff like that. And I'm wondering, because my understanding is he helped create Stack Overflow. He's one of the founders of Stack Overflow. And I wonder if maybe the reason Stack Overflow does have somewhat of a, I guess, vitriolic community, like somewhat rough community, is because maybe this guy has somewhat of a rough sense of communicating with people. I don't know. It's something I thought about recently, but I don't know. Gustorm kind of deserved it, though. I don't think Gustorm deserved it. Also, you probably know Coding Train, Coding Rainbow. Oh yeah, those guys are great. Coding Train. If you haven't seen it, let me just look this up. Coding Train. There we are. He has the best intro ever. I love his YouTube intro. Let me just pop this over here and pop it over there in case you haven't seen it yet. Very good stuff. He was on Twitch at the beginning, only hate directly to him, and now he got a lot of followers. Oh yeah. Yeah, that's true. You said coding. Yeah, I'm sorry, I mispronounced it. Eagle X. You want to get the toxic mood going, don't you? Me, personally? Oh, Buttercake, yeah. They don't insult, they attack your question, which is fair game. I think that's also true. Like, here's the thing. For me personally, like, if I'm coding here, I get a lot of comments from you guys. Not so many. You guys are a very nice community, but some comments where people are like, hey, why don't you do it this way? Or hey, why don't you do it this way? Or hey, that was stupid. You should have implemented it this way. And to be fair, Gustorm is one of those people that is very blunt about his opinions. You know, if he sees you doing something stupid, he'll be like, hey, that was dumb. You should do it this way. And that's very rough. The way in which people communicate to you or communicate to me is sometimes very rough. Because I'm in the middle of programming and I'm kind of thinking as I'm programming, and a lot of the things I do aren't quite right. And I know that. So when people mention, or when people say that how do I put this? That I'm doing things wrong, sometimes I do get offended, you know? Because it feels like they're directly attacking me when I know they're not doing that. They're directly attacking what I'm making, which is probably a piece of crap because it's programming and that's what everyone says. The thing is, if you're coming from another community, a community that's not used to this very blunt way to describe other people's work, it can be very, how do I put this? It can be very rough. It can feel very bad. Like, it can feel like all this work that you put your heart and soul into is bad, you know? And in some sense, I kind of agree with what you're saying, Gwenerth, that if you ask a question and the question is somehow illy phrased, or, you know, it was an obvious answer, you just did something stupid, or any of this kind of stuff, I understand, like, you know, that was your fault, not the fault of any of the people who are wasting their time answering your question. On the other hand, you know, one of the people recently committed to the algorithm archive, and he got a lot of comments on a lot of the how do I put it? A lot of the commits that he made, or the pull requests that he made, because the way that he was doing it was slightly different than other people did, because he was new to Git and version control and all that kind of stuff. So, you know, he didn't really know what to do, and it was kind of complicated for him and all this kind of stuff. And I felt kind of bad for him because this was his first time committing. He was new to Git and version control, had no idea what he was doing, and people kind of tore him to shreds a little bit, and I was fine with it, and I'm sure he was fine with it, but I'm wondering if other people aren't fine with it. So I almost feel like I agree with what you guys are saying. On the other hand, I really feel like maybe we should be a little bit kinder to some people about that kind of stuff. I don't know. It's just something I've been thinking about a lot recently. Like, as a programmer, you kind of develop a thick skin, you know, because you know your code is crap, and when people say your code is crap, you don't often defend your code. You're like, I'm sorry, let's make it better, you know? But if I went to a researcher and I was like, hey, your research is crap, or if I went to, I don't know, a doctor and said, hey, your doctoring is crap, I don't really know how that works, but I'm going to assume I could say that to a doctor, this would be not okay. But somehow it's okay to tell people that their code is crap. It's like going to an artist saying your art is crap, you know? No, it wasn't that you guys were mean. It was just that there was a lot of comments that came up during this pull request. I'm not going to show the pull request. I think it's fine. At least you never made a bot that reposts links made by bots and failed to fix it. Oh man, Buttercake. But Buttercake is so great. I like Buttercake. I like everyone in this community. This community is amazing. And I know I say that all the time. It wasn't that you attacked the guy. It's just that he mentioned afterwards that it was kind of information overflow. It was in particular, I guess I can show it to you. GitHub. Art gets torn to shreds, though. At least you can print out shreds. Hey, I think I fixed it. Just stop testing. All right, seems fixed. Okay, so we're gonna do pull request. Good job, Buttercake. Okay, I haven't checked these pull requests yet. I will check them in the near future. In fact, directly after stream. The one I was talking about was probably this one. It was just between GA and JSPP, and it was just kind of like a lot of talk here. And GA was like, I'm sorry, I have no idea what I'm doing. Maybe I got it wrong. And I was like, no, you're fine. You're fine. Don't worry about it. Your commit messages don't contain enough cat references. The Gel Mega, I guess. Hey, what are you working on? I'm working on a basic visualization of the Euler methods and stuff like that. We've got this pretty cool visualization so far. I guess I can just run that again. I really like it. It's fine. I don't have it up right now. But basically, we're working on Euler methods right now. Going to put it in the algorithm archive after that. And then make a video on it. And basically describe Euler methods to everyone for fun. That's the whole thing. It's kind of a weird channel, I understand, if you're not interested in this type of thing. So animate line, start frame, end frame. The idea is we're going from vector array I-1 to vector array I, and that should be correct. I don't see a problem with that. The problem is that for some reason, the line is not drawn afterwards, so I think what I need to do is also... Oh, I know what I need to do. I have start frame array, but what I need is an end frame. Start frame array, animation, start frame array. Wait a minute, what? Okay, I gotta figure this one out. Let me take a look at what we have for this animate line function. vi source, vi actually Cairo viz.cpp. And let's take a look at this animate line. Animate line. There we go. Looks like I have a start frame and an end frame. But what I actually want is start frame, and I think I failed miserably at this part. What I actually want is this to be end frame. 1 second, I gotta think here. And then we just put DT in there, and that should be okay. Oh, no, it should be start frame array plus current time. This is what it should be. So I want that, and then here I want end frame. Let's go over here, and let's see what happens if we right quit and make that. And now let's see if we do the last visualization test, and then run the last mirage. We should be okay. Okay, so now we should see, hopefully, unless I'm a complete idiot, we see the graph being drawn. Here we have the graph being drawn. Come on. And then after the graph is drawn, we should see... Ah, dang it, we don't see it. What are we missing? So there's the final graph. Okay, it's still going backwards for some reason. I'm not exactly sure why it's going backwards. And then it's disappearing. Dang it. What has 2 legs and bleeds a lot? Clifford the big red dog? I'm not sure. I try to behave quite kindly, but okay, I'm proud of you. Oh, that basically I was dumb. Confused, as modern people say. No, JSPP. That's the thing, that's what I was saying. Our community is very nice. Like, super nice. I really, really like our community. However, there can be a bit of information overload for some people who are completely new to, let's say Git and version control. And I agree with what Gustorn was saying the other day, that we should just give people Git and version control and just let them figure it out and learn it, because they should learn it. But, wait, did I miss something? Half a cat? Oh, oh man, T2 designated, that's so sad. Gathros on Discord. Leos is talking about how the community is ripping someone for commits while this is happening. Basically, Buttercake and Gustorn helping Gathros out with commits since yesterday. I mean, the truth is, you guys are an amazing community. I know I've mentioned this a lot. I was just mentioning that. Let me spin this the other way. I like the fact that you guys are so nice and helpful and friendly. Like, it's the exact community that I wanted. I've always wanted just a group of people that enjoy programming together, and this is one of those projects that can really just do that, you know? We cover an algorithm, we go through the algorithm together, that's super fun. You know, the stable marriage thing that we did last week was probably one of the coolest things I've seen our community ever do. Just kind of gather around and try to figure out how to do the stable marriage problem together. I thought it was amazing, and it was super fun, and I don't know, I just enjoyed that. Like, that was that was one of the most, one of my favorite moments, I think. They're helping Gathros really great since yesterday with Git. It's really cool. Yeah, right? It's amazing. I'm sorry. I like this community a lot, and I don't want to do anything to like jeopardize it, you know? Like this is why I'm asking you guys so many questions about what you guys want, because I don't want to like accidentally do something to lose any of you people, because like I don't know what it is, but like every night or whenever I chat with you guys, I'm always happy. Like especially like, I don't know, it's just amazing. You guys are great. So don't change. Okay, so let's see if we can figure out what's happening with this plot thing, because it's going backwards, and it shouldn't be going backwards, but it is going backwards. So let's see. It draws the entire plot at the start. That seems a little bit weird. So we give it some start frame, which is equal to start frame plus current time times animation FPS, where current time is equal to I times dt. So start frame would be plus 0 plus whatever I times dt is, so on and so forth. Then we do end frame, right? And end frame should be read in. So that means we should want to keep this plot available until that end frame. And then we go from there. dt vector array -1, vector array I, array color should be okay. Yeah, I'm sorry, I didn't mean to get sappy. Sometimes I do, just because I really like this group and I really want everyone to stay together. You know, it's super fun. Okay, so let's see if I can figure out what's happening with this. I once forked a Git repo of a Jekyll website and changed something and did a pull request because I had no idea what I'm doing on GitHub. The owner gave me a warm welcome and wished me good luck with the website. Oh, that sounds really fun. My only wish is in this world is that James is doing something with cats. Are there cat algorithms? I mean, there's Schrodinger cat. Oh my gosh, Schrodinger cat. I can't say it. I cannot say it today. Cat algorithm. Let's see if there's a cat algorithm. We might be able to do cat swarm optimization algorithm. Actually, what the heck is this nonsense? Cat swarm optimization? What does that mean? The heck? In this chapter, a brief literature review of the cat swarm optimization algorithm is presented. Then the natural process, the basic CSO algorithm iteration procedure, and the computational steps of the algorithm are detailed. Finally, the pseudocode of the CSO algorithm is also presented to demonstrate the implementation of this optimization technique. That's an optimization technique. I guess that's fair from Swarm. Maybe there is something there. Oh, this is amazing. Practical adaptive cat algorithm. Man, okay, fine. There are cat algorithms. Let's see. Here are the core steps needed for practical depth testing of the rash model. I don't know any of this, but I have to look into it. Oh, that's amazing. Okay, maybe we do a cat algorithm soon. All right, that might be in the future. Okay, let's see. What do we do next? So the animate line function. We start by taking the time. We say we start at this frame. What happens if we don't add the end frame? What if we just remove this guy? $, right here. Go over here, make that. Run the last visualization test and see what happens. Let's run the last mirage. Hopefully this works. We draw it here. Okay, wait, maybe this works. Okay, so this one seems to work just fine. So the array is still there. And then, oh, the array is still there. It is on layer. Man, I really like this visualization method. It's dumb. I know it's dumb. I'm dumb. I'm sorry. Let's go to end frame. Cat algorithm. Are there dog algorithms? Let me see. Are there dog algorithms? This is a good question. Dog algorithms. Algorithm will train your dog. Let's run viz test. Difference of Gaussians? Oh, difference of Gaussians. Dog. Ha. Ha ha. Imaging science. Difference of Gaussians. Oh, I'm sorry for the yawn, guys. Is a feature enhancement algorithm that involves the subtraction of one blurred version of an original image from another less blurred version of the original. In this simple case, subtracting one... In the simple case of grayscale images, the blurred images are obtained by convolving the original grayscale images with the Gaussian kernels having different standard deviations. Blurring an image using a Gaussian kernel suppresses the high-frequency spatial information. Subtracting one image from the other preserves spatial information that lies between the range of frequencies that are preserved in two blurred images. Thus, the difference in Gaussians is a bandpass filter. Oh, that's interesting. That discards all but a handful of spatial frequencies that are present in the original grayscale image. That's actually really cool. Okay, so the idea here then is that we have, how do I put this? DOG makes nonlinear images, dogs rule. So the idea with the difference of Gaussians is we perform a Gaussian blur that blurs out a certain frequency of images. Then we perform another Gaussian blur, which blurs out another frequency of images. And if we subtract the two, we have kind of the difference between these frequencies. So we can get specific frequencies of images from our particular frequencies out from our image. And that's really cool. I think that is actually, I like that one. Let's do that one. At some point. I mean, we have convolutions, so we need to go through like the Gaussian stuff at some point. So let's just see what happens when we run this Mirage, and hopefully this works. Otherwise, I need to figure out why the end frame stuff isn't working. So give it just a second to load, and hup. Sorry for that. So let's scroll down. Yeah, okay, works perfectly. Great. I'm a big fan of this now. So we have the plotting function. It plots stuff, and then it goes away at some time. Man, I like this. Big fan. Okay, so what are we going to do next? So next what I want to do is go back to the Euler method stuff. Again, I expected to finish this around 6. We finished around 6. So I'm going to quickly write and quit here and do a git status on the current directory and add git add kairoviz.cpp. Now we're going to cd back into the Euler methods, and we're going to use this function that we just created. Now I'm going to leave a terminal up on the side here for the visualization stuff, I guess you could say. So like this is in the visualization library, so that I can always take a look at that if I need. And I'm going to cd into projects Euler. Okay, simuleos Euler. Okay, I just like that Gus Run quote from Discord. These steps should un-F your repo. James immediately decides to do the dog algorithm, conveniently forgets about the cat algorithm. Today I learned James is a dog person. Whoa, 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 whoa. So actually, my friend has a dog whose name is Sudo, S-U-D-O. I really wanted to get a dog and name it Sudo, because if you give a dog commands, right, you have to say sudo sit, or sudo heal, or sudo whatever, and it's just amazing because, you know, like, you're teaching the dogs tricks, and you have to say sudo beforehand. And I wanted them to be able to teach the dog that if you don't use sudo, if you just say sit or something, the dog becomes belligerent, you know? He's like, I don't want to do that. But if you say sudo sit, it will sit, you know? Like, I really wanted to teach it that so that, like, you don't have permission unless you say sudo. But that didn't work. Oh, well, I mean, it worked. I mean, they have the dog. But unfortunately, that name is already taken by that dog, which stinks because I really want to name a dog that name. I was actually having a discussion with this person. I was having a discussion with this person a while ago, and she was going to name the dog Boson or something like that. I was like, no, I've always wanted to name a dog Pseudo. That would be amazing if I could name a dog Pseudo. And she was like, actually, that's a really good name. I'm naming my dog Pseudo. I was like, no, I want that name. And then, what was it? The other day, we had this programming conference at OIST, you know? And so we were walking around, and she was walking Pseudo, and she was like, Pseudo, come! And everyone just, like, flipped out. They were like, that's the best dog name I've ever seen. It was so cool. I don't know, I'm such a big fan. So then the only other thing I think I could want as far as a pet is a pig named the following, Niels Bohr, for obvious reasons. So I wanted kind of a pet pig because Niels, did I spell it right? Niels Bohr? Yeah, maybe I misspelled it. Yeah, I did. It's I-E instead of E-I. But that's the only other thing. It's not nearly as good as Pseudo. I mean, this guy's a famous physicist and everything, but come on. Anyway, that was about it. I actually like both dogs and cats. My opinion is that cats are great if you're not home a lot. But dogs are great if you are home a lot, you know? Because dogs require more attention than cats. In my opinion, they seem to. Okay, so I think that's everything I have written down for things I could potentially talk about during this stream. So now for the next hour, we actually can get work done. That's pretty cool. First time that's ever going to happen. So let's go into vi Euler.cpp. Come on, I know it's here. Okay, so now the question is, what do I want to do with my life? And the answer to that is I have no earthly idea. So vi, what am I looking for? I guess it's going to be Cairo viz.h. And pop down here and change this to 1,000 frames again. And again, I'm just going to run the visualization we have right now to kind of describe the situation we're currently at. So I'm going to make this real quick and run ./Euler. Okay, so right now we generate 1,000 frames that looks like the following. I don't know if I mentioned it, but we have a school dog. Oh, that's really cool, actually. I kind of wish we had a school dog or something like that growing up, because I like dogs. I like cats too, but I don't know. It's okay. I speak very little Japanese, not as much as I should. I mean, I know I live in Japan, and I should be able to speak a lot of Japanese, but I don't, and I'm really sorry about that. I have to apologize, like, literally anytime anyone asks me. Okay. So give this guy just a second to run. I'm also going to lower the resolution from now on to again be 600 by 400 to make it so it runs a little bit faster. This is of course one of the big downsides to using Cairo instead of OpenGL. It takes a lot longer to generate the images and stuff like that. But for a low resolution image, few frames, it's also pretty okay. So I'm running the last mirage. Okay, give this guy just a second to load the images and then we can scroll through it. Yeah, I don't know. Big fan of this community. Let's see. Removing that, removing that, removing that. Got a whole bunch of notifications. Should be good. Okay, so let's scroll down a little bit. So here's the original planet being generated. Here's all the balls on the side. Here they are all moving around. Super cool. Big fan. Yeah, that looks pretty dang good. All right. Cool. So we have our visualization there working. So now let's work on the next visualization, which should be relatively straightforward, all things considered. So let's talk about how the Euler method actually works, and hopefully we can get some sort of very basic visualization working. Does the average Japanese person speak English fluently? No, they do not. However, I would like to say that I work at OIST, which is a completely 100% English-speaking institution. So even though the average, I guess you could say, Japanese citizen doesn't speak English that fluently, it doesn't really matter because I work at a place that speaks exclusively English. So there is that. Okay, let's move this over here on the side and let's get this done. So what I'm going to do for now is I'm going to comment this guy out. And what I want to do is create a new function, which is going to be called, function, one of these days, function, one of these days I'll spell something correctly, function, there we go. To visualize. I guess I'm going to say error propagation, but I want to say instability. So what I'm going to say is visualize, and I'm just going to call it instability. And similar to above, let me think here. Do they put corn on pizza in Japan? I guess every once in a while, sure. No, let me think about the best way to do this. So I think I've got a lot of these things being created here. So I think what I actually want to do is send in a scene instead of sending in wait, actually, where is one second, where do I do all the visualization stuff? Oh, here it is. SC frame layers equals init scene. I already have that. Let's do it that way. So G down here, and we're just going to say something like this. std vector layers equals init scene, something like that. Corn on pizza? Nah, pineapple is evil. Is the evil? Okay, so what I'm going to do very simply is I'm going to go through and open up the file over here, go into cairoviz.h, pop down here, and I'm going to use this function really quick to basically go through and generate all of the images we need, or generate all of the generate a simple plot. Okay, that's what I want to do, just generate a simple plot. And on top of that, we're going to plot other things. So I have to kind of think about the best way to plot other things on top of the plot. But that's okay, we'll get there when we get there. Okay, so we're going to go here. And basically what I'm going to do is just plot something very basic. So I'm going to create a very simple array, and I guess I'm going to fill it with 100 elements, say it's equal to x squared or something like that, and see what happens there. So we're going to say std vector, that's not how you spell vector. One second, vector, there we go, of double. And I guess we're going to call it array. And we're going to say it's a size 100. And basically, actually, wait. What's your guys' favorite function? Tell me your favorite function, and we're going to go from there. Let me also do for, I guess I'm going to say element. How do I do this? Double element for it, just grid. Int I equals 0, I less than n, and I guess I'm going to define n here. 1 second, guys. And then we're going to, what kind of function? Any kind of function, like sine, cosine, tangent, whatever you want. I guess we can do that. Anything fun, but not Batman function. Something simple, something that I can just very easily put onto this guy. So plus plus I. This song. Pop down here. Non-sensation. Do I get this right? With Cairo, you create images, or Cairo and OGL Raptor? So with Cairo, we generate basically a bunch of images. That's what we do. It's a vector drawing library. So the idea here, in the case that it's not clear, because I figure it probably isn't clear, the way I have this set, let's just go over here and open up a new terminal, type in Zernal, and I'll draw this out for you so it kind of makes more sense to you guys. For double element, yes, I could have done that, but I decided against it in the last minute. Okay. Let me pop this over to the next desktop, move that over there, there. Okay, so the visualization library. Okay, here's the idea. We have an image, right? Cairo is a vector drawing library that draws onto this image, right? So we can do a whole bunch of different drawing. We can draw circles, we can draw lines, we can draw a whole bunch of different things. Now for an animation, what I do is I generate a bunch of these images put together, right? So this, plus this, plus this, plus this, all these images put together. Now in each of these images, we have a set of layers. So let me see if I can draw this. So I usually just generate 3 layers on top of each other. Actually I did this wrong. I usually generate 3 layers on top of each other, and I usually draw on the middle layer. This is so just in case I want to draw something above or below, I can very easily do that. And that's kind of the idea. So we have 3 layers that are repeated over and over again for every time frame. And then we just generate all of the images, and then after generating all of the images, we go and concatenate them all into a single video. So that's it. It's super straightforward, especially when compared to OpenGL. There's no trick here. And on the positive side, because it allows us to generate all of the images, image by image, it means we don't have any resolution issues. There's no way that we could possibly skip frames. There's kind of some benefits here. Obviously a lot of drawbacks in that it's not real time, that we have to wait for it to generate and stuff like that. On the other hand, it's also kind of nice that we can scroll through the images and figure out what we need to do. So there's benefits and drawbacks to everything we're doing here. But in the end, I'm trying Cairo again for this one because I like Cairo. It's good. So the Ackermann function, I actually don't know. Ackermann function, simplest example of well-defined total function. Let me see what we have here. We're basically drawing frames, yep. So A is defined for integer. Oh, so it's just y plus 1? 2y plus 3, 2 to the y, wait, what? A to the 4y. I'm not sure I understand what this is doing. Let's see, A of 3y is 2 to the y plus 3 minus 3. To the y plus 3. Let me take a look at this real quick. Yeah, we're basically drawing frames. That's exactly what we're doing. So let's see, the Ackermann function. I guess the Ackermann function, if x equals 0, if y equals 0, ax minus 1. Oh, that's a huge pain to implement. Screw it. I'm not doing that. I'm sorry, Gwenarth. I mean, I realize you probably wanted to see it, but I mean, I'm just going to do sine. Just, yeah, fine. We'll do sine of, I'm sorry. It should be 2 times m pi. 2 times m pi, and I guess it should be I times 2 times m pi divided by n, or something like this, right? I don't remember what it's supposed to be. I'm sorry, Gwenarith. I don't know how to do that one at this point. Something simple is what I needed. So I need to do array of I is going to be equal to the following. Okay, so we have this. I times 2, is that correct? I want it to go from 0 to 2 pi. I think that'll go from 0 to 2 pi. And this is why, who was it that mentioned? This is why non-sensation I wanted the I, because I knew I was going to have to calculate something that goes with time. And so I needed the iterator to go through anyway, so I figured why not just use it here. So we have I think this goes from 0 to 2 pi. Yeah, sure, seems okay. So now we have the array, so now we want to plot everything. So what we're going to do very simply is just say plot. Come on, I can do this. And I'm going to read in anim. Layers, actually. And I'm going to say layers of 1, just to draw on the middle layer. Array. Double time, which we're going to say is 1 second. Start frame, which we're going to say is 0. End frame, which we're going to say is, let's just say 300. And then we're going to say the origin, which we hadn't defined yet, but we can define here. So we're just going to say vec ori is going to be equal to 0, 0, 0. And we're going to have to do the same for color. But in this case, we're going to do some different stuff here. So I guess for the bar color, we're going to 0.5, 0.5, 0.5. And I guess it's also going to be 1 here. And I think I failed to add a 1 there. No, that's correct. That's what it's supposed to be. No, I want color. 1 second. Bar color. And then I want plot color. 1 second. Okay, why don't we change the plot color a bit? Let's see, red, green, blue. I want to make it blue. So let's just do 1 here. And then we're just going to go down here and we're going to add it in there. So we have let's see, 300. Vector origin. I forgot the dimension. So we're going to say origin. Then I'm also going to add dimension. And then we're going to add bar color and plot color. Something like this. And then we just pop up here, grab the dimension. And the dimension here is going to be the size in the X and Y. So I guess we're going to say it's going to be, let's take up a good bit of the screen. So we'll say 300 in X and 200 and Y. Let's go over here and write it and see what happens. Make that. Great, okay. Visualize instability. That's because I forgot something with no type. Oh, that's because I'm an idiot. Void. Write this. Layers, missing arguments before layer. SE vector layers. I need vector of frame, I think. Make that. What else am I missing? Vec ori, redeclaration of vec ori. Did I already have ori defined? Oh, I did. I need to define this as dim. This is just messy code, guys. I'm sorry about that. This one seemed to make, so let's see what happens if we run Euler. Oh, you know what I forgot to do? I think I forgot to draw layers at the end. Let's do draw layers. That's not right. One of these days, I'm going to be able to figure this out. Layers. There we go. Nope. Wrong terminal. Make that. Okay, now let's try Euler. Also seemed to run just fine, but that shouldn't be the case. Why did that run so quickly? Let's try running Mirage. Give it a second. Oh, ha. You're right. I'm sorry. Thanks for letting me know. Gwenerth and Mendelarium, thanks for letting me know. I totally did. Let's make that. Now let's run Euler. This needs to do something. Great, appreciate that. Segmentation fault. Don't appreciate that. How could this possibly be a segmentation fault? There's like literally nothing that I'm doing. Anyway, let's run GDB Euler. And let's run that. And I'm gonna quick backtrace. Visualize Cairo. Visualize instability at 124. It's of course in this function. And Cairo vis 902. Let's take a look at what we have there. 1 second. There we go. Cairo vis.cpp. Then we go to 902. here, double max equals max element of array dot begin, array dot end. Am I doing something wrong there? I'm using GDB, yeah. It's easy to use for this. It's hard for me to use for the scientific visualization library, but it's relatively straightforward for me to use for this library. Okay, so let me see. Why is this happening? It says double max element here. Does it give me any other errors? It just says at visualization 902. I'm at 902, I believe. Yes. So it's having a problem with this guy here. Max equals max element of array dot begin and array dot end. Maybe you're not giving the correct array dimension to the plot. Why use visual debuggers? Yeah, good question. Maybe you're not giving the correct array dimension to plot. Maybe. Let me see. So we have the dimensions here. But it seems like all I'm reading in is a vector. It should be okay because the array should be a vector.size. Also, n has no value. Oh my gosh. Thank you. I don't know what I'm doing, but I'm doing everything wrong today. Appreciate it. That's probably the issue. Control D. Yes, make that. Let's try this again. No, I don't want to. No, what am I doing? Control D. One of these days. Euler. Okay, that seems to work. Thanks, Non-Sensation. Really appreciate that. Don't know. I think Buttercake was getting at that. Also, I like to have breakpoints and now where the code stops. Yeah, you have both in GDB. It's fine. So the thing is, I don't know. Let's go ahead and run the last Mirage. Okay, let's see what happens here. We should see something. Okay, that is something. Great. All right, perfect. That's not what I was expecting, but it's something. So I need to move the plot down. 0, 0, 0 obviously isn't the right location. So what we need to do then is drop it down a little bit. So let's move this to where it's supposed to be, which isn't 0, 0, 0. I apologize for that. It should be layers of 0 dot x dimension, resolution x times 0.5. It should be the same for resolution y. Write this, go over here, make that. Layers, not layer. So let's go ahead and do an AS there and an AS here. Write that, go over here, make that. Kind of worked. So let's do the Euler here and see what happens. Hopefully we see a plot. That's all I want to do. I just want to see a plot. You know what I mean? Like some days the only thing you want is just to see a plot. And that day is today. Okay, so let's do Mirage. Move this over here, see what happens. Okay, there's the plot. It looks good. Boom! Got it. Okay, so there's our plot. Got it, guys. Yep. Okay, I don't know why I just... Yeah, okay, let's go. I guess I also want to change the color of the bar color. Let's change that to white. I'm sorry. I know it was so much work for so little results. Let's do this. Mirage, see what we got. Alright, wait, no, that's not white, that's still gray. I want to do it white. Let's run the last Euler. Okay, so now what I need to do is, let's see, what do I want to do? I want to find a way to visualize the errors in the Euler method. Laos bro? Wait, what? Laos bro? Bro? Wait, I remember this. What was this from? Let me go ahead and get some stuff done over here real quick. Good, okay. So what am I going to do then? I'm going to run the last Mirage, take a look at this. What's the algorithm we're visualizing? We are working on the Euler method. So right now, what I was just doing is checking the plot just to make sure we can plot it relatively straightforwardly. I feel like I need to give this guy more time to draw. Let's give it some more time. So let's say instead of 1 second, let's give it, let's see, if we have 300 frames, then technically we have 10 seconds to work with, right? Am I being stupid here? 10 seconds here, and let's actually give it more frames. Let's give it 500 frames. Go over here, write that, make that, see what happens. And then we're gonna go to Mirage Euler here. I just want to let it draw for a little bit longer, you know, give it some time to figure out what it's doing with its life before doing anything from there. Okay. So the Euler method, in case you guys were not familiar, we did the Verlet integration stuff earlier, and Verlet integration is somehow related to the Euler method. It's just that Verlet integration is, I guess in some sense, easier than Euler method. So the Euler method is more general. I guess you could say it's a more general version of this. So the Verlet integration is kind of like specifically for moving objects in like gravitational field, like via the kinematic equation. The Euler method can be used for any general ordinary differential equation. Yeah, that looks way smoother. Look at that. Look at how smooth that is. Boom. Great. That's awesome. Okay, good. Big fan. Okay, so let's go from there. So now we have the plot. Let's talk about what Euler methods do, and let's see if we can figure this guy out. New page before. So in general, the Euler methods are an ordinary differential equation solver, like I said before. So if we have an ODE, just something very basic, nothing complicated here, this would be dy over dx is going to be equal to, let's just call it x squared over 2, okay? To solve this, we say dy is going to be equal to x squared over 2 dx. And then we basically do the integral on this side, and we'll say y is going to be equal to x cubed over 6 plus c. Something like this. Super straightforward. Lance Bros from Cool Gun Stream. Oh, clip not found. Oh no. I guess the clip goes away after so long? I'm not sure. But yeah, so this is the basic answer here. So the reason I chose x squared over 2 is because we also need to use the derivative for the Euler method. So the derivative of this guy will just be x, which is super straightforward. Okay, so let's see if we can figure this guy out. Again, there's going to be a little bit of trial and error here as we figure things out, but we know the solution is x cubed over 6. So what I'm going to do is go ahead and read that in there. Oh, it's there. I'll take a look at that later. I'm sure I've seen it before. So what I'm going to do is change this now to x cubed over 6. Let's see, what do we have here? And that will be the analytical solution. So x, I guess x cubed, then divided by 6. So times 0.166666. Or I could just divide it by 6. Yeah, probably dividing by 6 is easier to read. Right over here, make that. Oh my gosh, there isn't an x. So I guess it's going to be, oh, we have to have some x dimension here. So let's say x is going from 0 to 2. So I'm going to say it's going to be equal to I times 2 divided by n. And the thing is, we have to make sure this is in, or something like that. Yeah, whatever. You know what I mean. It's done. Oh, what am I doing with my life? Double and into binary operator. Oh, that's because that probably doesn't exist. So it's probably pow that I'm looking for. Make that. The Gel Mega, gotta go. C-Man, thanks so much for coming in. Really appreciate it. I apparently cannot use that in C++. Just learned that. Yep, so let's see what happens if we do the last Euler and see what we got. So this means we should have like an n cubed type of guy going from 0 to 2, hopefully, unless I'm an idiot, which, as you guys know, is not too far off of the truth. Okay, so now let's do, what do we have here? Mirage temp. Let's take a look at what our plot looks like. Here's the drawing of the axes, and then we should see, look at that. That looks pretty dang good. Okay. I'm sorry. I am a complete idiot. So now we're able to plot things very basically. It should be bitwise, or yeah, I know I was being stupid. I'm sorry. I don't know why I was thinking that would work. I've been doing too much LaTeX recently. If you know what I mean. Heyo, up top. That doesn't mean anything. I have no idea what I mean. I'm sorry. Okay, let's go. So what we're gonna have to do now is probably plot some other stuff on top of this stuff. So we can do a plot on top of a plot if, you know, you really like plots. But I kind of feel like the best way to do this is just to like create another function to add to a plot. But for now we have to kind of figure out how to deal with this this array. So let's go ahead and talk about Euler methods again real quick. I've mentioned this before. If you go to the algorithm archive, I do have a chapter on Euler methods, but it's not very good. The chapter on Euler methods right here, it kind of is trying to lead into the Barnes-Hut algorithm, and you can clearly see that when you read it. So what I want to do is make this more general, which is why, again, the video is not coming out this weekend. It's going to be coming out much later. Also, there's clearly a typo right here. Why is there just a plus that leads to nothing? I don't know. But anyway, the idea is somewhat straightforward. I usually start by talking about the Taylor series expansion because this allows you to kind of more easily determine what's happening. You know, like it allows me to think about things easier, because when I think about the Taylor series expansion, I tend to think that kind of kinematics, and kinematics to me are straightforward because I guess maybe I'm a physicist. However, this particular chapter isn't particularly great, if I'm being honest. It's not so great. So that's something we have to look at. But the idea is rather straightforward, right? So we have some sort of derivative of some function of x, right? And that derivative leads us to the integral in a way. So if we have x, x of the next time step will be x of the current time step plus the velocity times some sort of, well, x time step, which they'll call h or something like that. Yeah, this is completely wrong, whatever I have here. So I'm definitely fixing this tomorrow. Maybe not on stream, probably off of stream, but it's something that definitely needs to be done because this is not clear at all and it doesn't really make very much sense. In fact, I would argue that the Euler method chapter is the worst chapter we currently have in the algorithm archive, which is why I wanted to cover it and just fix it up, because it's very not okay. Yeah. I'm also thinking about changing the mathematical background to mathematical methods. So I'm going to call it mathematical methods instead. Reason being that these are methods that you still need for doing things. Like, for example, the convolutions are here. So if we change it to mathematical methods, then we have the ability to go through some other stuff that people have recently talked about on the channel. Like, for example, someone wanted me to do the radon transform, which is super interesting. Isn't necessarily an algorithm. Let me see if I can put this on Wikipedia, just because I like Wikipedia better. But it's a super interesting thing used in a whole bunch of different, like, tomography stuff. So I'm very interested in trying this out because it seems very interesting and I want to give it a shot. And it looks very visual, but it doesn't quite fit in the current archive. So if I change mathematical background to mathematical methods, then we can do some of these kind of neater mathematical visualizations and still have them be relevant, because these are computational methods that people will use. It's just not necessarily called an algorithm, but it's still a method, you know? And so I figure it does kind of fit, but maybe not. So this is something I was kind of tossing up and down recently. It can be done pretty easily in a number of different methods with a Fourier transform and other stuff. So I think that's kind of neat. Okay, so let's go ahead and talk about what we need to do here. So what we need to do is solve for the Euler method here with some sort of time step. So let's talk about what we need for this function. So I guess what I'm going to do, I'm going to return a vector of doubles. So we're going to say vector std vector of doubles, and this will be for the Euler method we're solving. In principle, we're only doing a 1D solution here. Again, guys, if you have any comments, questions, concerns, feel free to let me know, and I will address those comments as soon as I see them in chat. So here we're going to say solve Euler, I guess. And what do we need to read in? I think for this case, we don't necessarily need to read in anything. And the reason I think that, we could read in a function, don't get me wrong, and then we could find like some sort of Euler, we could solve that function with the Euler method or whatever. But I don't think that's what we want to do. I think instead all we want to read in is double step. And then the idea is that we step through with a different step, basically. So we find out how many elements we need in our system. And then we see what happens with different time steps. And we see what the plot looks like. And I guess we want double step, and we also want double x max, something like this. So then we'll just work through, and then we return the vector of doubles, which will be the Euler array at the end. So what I'm going to say here is int n is going to be equal to x max divided by step. Is this correct? I think so. So if I change this to an int, we should be okay. I mean, it is definitely going to be called an int. I just want to make sure it's casted correctly. You know, Maybe I should do floor. Nah, I'll just do int. It'll automatically floor, right? Okay. Now what do we do from there? The next thing is we have int n, so now we have to create a vector of that size. So std vector, that's not how you spell vector, let's do it. We'll call it double, and we'll say Euler output of size n. And then in the end, we're gonna have to return this. So return Euler output. One of these days, I'll know how to type, but again, not today. Let me get some more water, and then we'll keep going from there. So then the idea is we just solve this iteratively every time step. Okay. There's a lot of chat happening in the Discord, right now if you're interested, by the way. Okay, so let's see. We're going to return the Euler output. We have n, which is a number of steps here, and we know what n corresponds to, right? N would just be every element in n would just be like oh, I don't know. It'll be like here. Let me describe it this way: for int I equals 0, I less than n, plus I. See, non-sensation, thanks so much for coming in. Have a wonderful evening. So now we know that the x location, double x val, we'll say x val is going to be equal to I times which step. Okay, so now we know the exact x location. And so now we just have to find the value from here on. So now all we have to say is basically solve the Euler method. And we know what the Euler method is in this case because we know the derivative of the function that we're reading in, because I chose a very particular function that's super easy to derive. So let's go ahead and do it. So we're going to say x is going to be equal to x naught, whatever it was before. So I guess we can say Euler output. Output is going to be equal to, of I, is going to be equal to Euler output. One of these days, put, oh my gosh, I minus 1, plus, 1 second. Let me also go up here and say Euler output of 0 is going to be equal to 0. So it starts at 0, and then we go from there. So we say Euler output of I minus 1, which is x naught, so plus, then it should be velocity times time, but if you remember, the velocity is just the derivative, so this is just going to be x val times, and then it should be step. Something like this. And that should honestly be it. Now we should be able to just work from there. Hey, Voice of Grog, how are you, man? How are you, man? There we go. I said something. I don't know if what I said was correct. So we have this, what I'm going to do now is I'm going to go ahead and read the solve Euler method in here, and I'm going to see what happens. I'm not really sure what will happen if we plot the two on top of each other. So what I want to do is create a function that will allow me to add to a current plot. And let me think, what's the best way to do that? I suppose, ideally, we'd have a way to determine what is a plot and what is not a plot. But I don't have that ability because I didn't read in shapes yet, or I haven't really created the shapes yet. So maybe what I should do is the following, and you're going to hate this, but it's something that should work in principle. So we have color, bar plot, bar color, and this is just for a quick test, just to have the two plots next to each other. Vector origin, and what I want to do is say, we have an array n here, and then we're going to go std array of, no, std vector, come on, I can do this, double, man, I just can't, Euler array is going to be equal to solve Euler of double step, and I guess what do we want the step to be? The other one has 100 steps, so that would be 100 steps between 0 and 2, so that would mean every step is going to be, let's just say 0.5 for the step, and x max is going to be 2, okay? And then we have this vector, and what I want to do is basically grab this guy, yank, paste. And I'm just going to do the same thing I have here, except I'm going to put down layers of 2, so it draws on top of the other one. And instead of here, I'm going to put Euler array. And in principle, this should make... It doesn't because I'm an idiot. This should be xval. 1 second. Make that. And let's go ahead and run that. I should tell you to update the SciVL repo from Gathros. I feel like I missed that. I mean, I can see the chat now. It loaded as of 10 minutes ago. So I can see the Discord chat now, or like 30 minutes ago or something like that. So in terms of updating the SciVL repo, let's talk about that in just a bit. For now, I want to run this, see what happens. Take a look over here. Okay, so we have this guy. 1 second. Then we should have 2. Yeah, look at that. Boom. Okay, so now what I want to do is change the color of the second one. So I'm going to say plot color 1 and plot color 2. I'm going to say plot color 2. And down here, we're going to say plot color 2. And let's make this other one red. So we're going to change this to 0.5, and we're going to change this to 1. So we can clearly tell the difference between the two. Now what I want to do is change the step here to 0.1. Make that. Let's see, Mirage. Ooh, let's do a couple more, just for fun. Yank paste. This is 0.1. Let's do 0.01. And I'm going to do plot color 2. And then we're also going to have plot color 3, which we'll call as green. Getting crazy over here, guys. This is amazing. It's actually not amazing. I'm sorry. And we're going to do 1 here. And change this to plot color 3. And change that to plot color 2. R3. Right here. And in principle, Euler array 2. Forgive me for the naming here. Ooh, that's not going to fit, is it? That'll fit, but now it looks ugly. Ah, fine. Bah. 1 second. Go here and there and pop this down to the next line because formatting. Okay, let's see what happens if we make that. That was not what I meant to do. Make that. And we should be able to run the last Euler, and we should now see 2 different plots, one of which should be significantly closer than the other one to the actual array that we're looking to plot. So we'll see what happens. And then we can start talking about these errors, but the thing I want to get at is instability, and that's going to be a little bit harder to figure out. So I got to think about that one real quick. That isn't an image. That's not an image at all. Let's try that. Give it a second. All right, wonderful. Scroll up. So now we should have this guy, and there we go. So we have red and green, but green should have been right on blue. 1 second. Why was it so far off? Should have been way closer. Let's try to change this to 0.5, just for fun. Make that. Euler. Give that a second to run. I don't know why it was so far off. That's kind of weird. But we'll take a look at it again. Hopefully this will be okay. And again, this is kind of where it would be nice to have the OpenGL stuff, because it is faster, the OpenGL stuff, than the Cairo stuff. Okay, so we're going to pop over here. Is that even any closer? I feel like this green guy is never going to get close to the blue guy. Unless I've done something incorrectly. What did I do that was incorrect? We have the exposition. Let me take a look at the Wikipedia article just to make sure I didn't do something stupid here. So Euler method Wikipedia. Just to make sure I'm not doing something really dumb here. So we say y of n plus 1, y of n plus h, a function where function is here. Some sort of function of t and y of t. Let me think. So we'll say y of n plus 1. So that's the y of the next time step. And what I'm doing is I'm saying that's called Euler output or something like that. It's going to be equal to the previous output, which is fine. And then h, and then some function that is dependent on the previous step. Okay. And some sort of x. Well, it is dependent on some sort of x, that's true, or t. That's fine. Let me see. Numerical illustration. What do we have here? Of why blue is Euler method, green the midpoint method, and red the exact solution. Let me see. What do they do here? They say f is equal to 1. Wait, y prime is equal to y. Y of 0 equals 1. We would use the Euler method to approximate y of 4. Well, there's something I'm clearly doing wrong here. I have to take a look at what it is. So again, guys, as far as I was mentioning before, yeah, I think it's super close. Man, what am I doing? Step size 1. I'm doing something clearly wrong here. I'm not sure what it is, though. So h should be the step, some sort of function of t here, and it should be... Yeah, there should be x plus velocity times time, where velocity is the derivative of acceleration. So, let's see. No, wait, x is a position. Velocity is dx over dt, yeah, okay. So, it should be the derivative of x. Wait. So if x is... Let me think here. The derivative of x squared over 2. That's why. I know the problem here. It's because I'm doing this incorrectly. This guy should be x squared over 2, not x cubed. That's what it should be. Let's make that. And then this should work just fine. So if we do Euler here, now the green should be right on the blue. Yep, that should be correct. So the green should be right on the blue, and then the red's going to be super far away. And this, again, isn't instability. This is an error. To talk about instability, I think what we'll do is we'll finish the discussion here today on errors, and then we'll talk about instabilities tomorrow. I think that's the best way to do it. Mirage here. Give it just a second to load, and we should see, come on, man. Green on blue, look at that. Green and blue right next to each other. Booyah. I think if I zoom in, yeah, it's kind of hard to see because of the rasterization, but green and blue are right next to each other. That's pretty happy with that. Let's see what happens if we drop the time step even further, which will create a huge array, but hey, I like huge arrays, if you know what I'm saying. I don't know what I'm saying, I'm sorry. Okay, so we're going to do Euler method here, see what happens. This is going to take a while, this one. Well, maybe not that long. We'll see what happens. I don't know. Okay, so now as far as the scientific visualization library is concerned, as you guys know, for the past year-ish, I've been working on the scientific visualization library. That library is basically an OpenGL library that is used for just doing all the visualizations I've done basically since I started the algorithm archive. So all the visualizations from Fourier transforms to trees and all that kind of stuff was done with that library. However, my opinion is that maybe we should stop developing the OpenGL side of that library. What I want to do, and I know this is kind of risky, but no one uses the scientific visualization library except for me, is creating a separate branch for the scientific visualization library for Cairo. And with that branch, what I want to do is basically take all of this stuff that we have here, move it into the scientific visualization library, so it's actually a library that is dependent on Cairo, and then use Cairo for the visualizations from now on. Now, I know a lot, this is kind of contentious. A lot of people liked the OpenGL, but the thing is with the OpenGL, there's always these weird implementation problems that I run into with OpenGL that I don't run into with Cairo. Cairo is easy for me to understand. It makes sense. It's clear. OpenGL, there's all these weird bugs that appear, and I don't know where or why they're appearing. Now, that said, the scientific visualization library is super straightforward. Like, it makes sense. It's clear. It's concise. But doing more difficult visualizations with it is much harder to do than doing difficult visualizations with Cairo, if that makes sense. Like, it's easier for me to do the visualizations with Cairo, and an added benefit of Cairo is that I get all of the images out, which means that if I want to play around with an image, or if I want to do something, rather than just screen capping things, I can more easily just play with those images. Meanwhile, with OpenGL, the only way I can get like image by image is by screen capping, which is kind of a big problem in my opinion. This means I can't do super high resolution stuff unless I've got a good enough computer to do the high resolution stuff. I don't know, there's just some weird things there. I admit I'm very happy with how far we got with OpenGL, but unfortunately I think this is the end of OpenGL. They're still not quite right at the end there. Let me try this one more time, but this time I want to change this to 4. And I want to change that to 4. And then where's the other guy over here? I want to change this to 4. That should be correct. Go over here, make that. So I'm just going to let it run for longer. A longer spatial step. So that's my current opinion there. I don't know what you guys think about that. In my opinion, I think it's better to move away from OpenGL. Again, I like OpenGL. Don't get me wrong. It's very, very good. But for this purposes, the purposes of this stream, the purposes of this YouTube channel, and for the algorithm archive, is it worth using a more difficult tool just to say we're using a more difficult tool? It's harder to do a lot of things because, like with Cairo, I get a direct image, which means that if I want to do something crazy with that image, like if I want to upload the image to the algorithm archive, I can do that relatively straightforwardly. It's harder to do with OpenGL. Now, on the flip side, OpenGL is better at doing massive visualizations and stuff like that. Like, for example, I wouldn't have to wait for the visualization to run. Instead, I could just do it in real time, which is what happens with OpenGL. So there is obviously the difference there, in that for Cairo, I have to wait a lot longer to get stuff done. On the other hand, I don't mind waiting a little bit longer. I just let things run overnight and I get the visualization done. So it's actually fine for me. I don't mind it so much. But that's that. Plus, the nice thing about Cairo on stream is that I can pause the video and I can kind of figure out what's happening and we can kind of look at things together. I don't know, there's a lot of benefits, and to get OpenGL to the point that Cairo already is would take a lot of work that I don't know how to do, and there's a lot of fiddling, and I've been fiddling so much with it. You know, at some point I just have to throw in the towel, and I think I will do that. Okay, so we let these guys run for just a little bit longer. Let's see. So let's see what happens. Yeah, again, so you see this red one, which had way fewer points, is significantly further off the blue and the green one. The blue and the green one aren't quite right, but hey, it's close enough. So now I'm going to go ahead and drop this time step down to 0.1. I'm going to run that, make that. I think part of the problem with this recent runtime, why it took so long, was just that it took forever to do the Euler method for that. We'll see what happens. Okay, and this will probably be the last run for the day. Back when I was running Ubuntu, running my PC overnight equaled my PC freezing up. Yeah, I've never had that problem, especially not with Linux. But again, fair enough. Everyone has different experiences. Okay, so now we'll see that even though we used drastically fewer time steps, we still got a very similar approximation to our system here. Now, one thing I really like about Euler methods is that this is actually quite amazing. Now, I realize the blue line is the line we're supposed to be hitting, right? And we're hitting the green line. I totally understand that we're not on the blue line, and that Euler methods are computationally intensive. But let me say something. That blue line is the exact solution. This green line is an approximation with basically velocity, you know? So this green line being so close to the integral of a system by using derivatives is super cool. And I just want to say that I'm a big fan of how this is moving forward. And I'm a big fan of Euler methods and stuff like that. I realize this is kind of pixely. I apologize for that. But yeah, I like what we did today. I think we got a lot done. Big fan. So let me also run the previous visualization, just because I like the previous visualization too. And let's talk about what visualization we need from now on. So let's make that. And let's see what happens if we run the Euler method. We get this visualization. And I want to talk about what it is we actually need for the visualization from now on. So now we're going to do, what am I going to do? Mirage here. So right now we have two visualizations. We have the planet visualization, which we did yesterday, which I think looks really good. Big fan of this one. And then on top of the planet visualization, we also have the instability visualization, which we'll hopefully finish up tomorrow, I want to say. So that's my goal, to finish that one up tomorrow. Now, let me think. What do we do at that point? After we have those two visualizations, I'm trying to think of what other visualization we need, and honestly, that might be it. So if we can get the instability visualization done, I could actually maybe get a video out this weekend. But again, the rule is the following. If I don't get the video out by Sunday night, if I don't finish it by Sunday night, I'm not going to put it out this weekend, I'm going to put it out next weekend. And the reason for that is quite simple. I don't want to keep rushing out the videos. The more videos I rush, the worse the content is on the algorithm archive, the lower people's opinions are of the entire project. It becomes one of those things. I don't want to, I want to start putting out good quality content, and that's something that I really want to make sure that we do well. Again, this kind of came in parts from when I was talking to Grant the other day, or 3 Blue 1 Brown. I was talking to him about it, and I realized he takes the time to do things right, and that's actually why he's so popular, I think, because he takes the time to do things right. Hey Michael, thanks for coming in. So yeah, anyway, the last thing we need to do is talk about instabilities. We talked about errors, so now we have to get a specific function that shows us the instability. And once we get the instability going, I really think that we can start talking about why we need backward Euler when compared to forward Euler, and then we talk about Gaussian elimination and we start moving on to that. Now, I have no earthly idea how to visualize Gaussian elimination. That's going to be a bit tricky. Maybe not. Maybe we can do it pretty straightforwardly. We'll see. We'll see what we want to do. But yeah, Michael, unfortunately you came at the end of stream. I stream from 5 to 7 o'clock a.m. Japanese Standard Time every single morning. Well, most mornings. I've skipped a lot of mornings recently, but most mornings. I'll try to stream again tomorrow, which is Saturday, my time, simply because I have some stuff I want to finish here. And I think that's about it. So at this point, yeah, 20 UTC, that's another way to measure time, I suppose. Big fan though. I know, I just read the Leos besties thing. We're not besties. I feel kind of bad because it's not like I'm name dropping his name or anything. It's just that was one of the better conversations I've had this week, and I'm happy about it. You know, like I'm happy that we had a conversation, that it looks like things are moving in the right direction. The guy's awesome. He's an amazing person. You should really check out his channel if you haven't. I know you guys all have, but if you hadn't, in the off chance, check out 3 Blue 1 Brown. It's a fantastic channel. And that's the thing. Like it's not like I'm trying to brag that I know the guy. It's just I'm trying to say that I liked the conversation I had with him, and that was kind of fun. That's about it. Okay, and I think that's going to be it. So I'm going to go ahead and commit this. Right and quit. Do a quick git status dot and git add Euler dot cpp. And we're going to do git commit dash m adding actually, yeah, whatever, dash m. I'm adding more to Euler visualization. Git push origin master. And now we should have this available for you guys to check out if you want to take a look at it. And again, guys, I really appreciate all the time that you guys spent hanging out on the channel. Super fun. Yeah, I'll be back tomorrow to do some instability visualizations. There's some other stuff here with the error that I want to plot too, because I want to kind of plot some points with the error so you can kind of see it clearer. And I think that's about it. So thanks guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, when we talk about instabilities and we talk about errors and we talk about Euler methods and we talk about life. Yeah. See you then. Bye, guys.